Good morning, students. In the previous classes, we discussed Newton's laws. We explained Newton's first law, Newton's second law, and Newton's third law. Okay. So, what is Newton's first law? Every object continues in a state of rest or of uniform motion in a straight line unless compelled by an external force to act otherwise. Okay. So, Newton's first law explains the definition of the force. Then what is Newton's second law? Newton's second law states that rate of change of momentum is directly proportional to the applied external force. From this explanation or from this statement, we can derive an equation for force F equal to ma. Okay. Then what is Newton's third law? Newton's third law of motion states that to every action there is equal and opposite reaction. Okay. These are the Newton's three laws. Okay. So from these laws we can explain conservation of momentum. So next topic is conservation of momentum. We know what is momentum. We know about momentum. What is momentum? Momentum is the impact produced by an object, or momentum is equal to the product of mass and velocity. So here we have to explain conservation of momentum. So for an isolated system, momentum is conserved. This is called law of conservation of momentum. That means total momentum before collision is equal to the total momentum after collision. Okay, for explaining this concept, we consider two objects. First object is A. Second object is B. The mass of the A is ma. Mass of B is mb. Okay, object A moves with initial velocity ua. Okay, next object B moves with initial velocity ub. If ua greater than ub, what happens? If ua greater than ub, or initial velocity of A is greater than the initial velocity of B, so A collides with B. Object A collides with object B. Object A collides with object B. After collision, object A and object B moves with final velocity. This is moving with velocity Va, this is moving with velocity Vb. So here three cases. First case, before collision. Second case is at the time of collision. Third case is after collision. after collision. Okay, these based on these three diagrams, we can explain the conservation of momentum. Okay, so first, before collision, object A moves with initial velocity UA and object B moves with initial velocity UB. If initial velocity of A is greater than the initial velocity of B, A collides with B. Okay, at the time of collision, there is action and reaction. What is action? Applied force is called action. Reactive force is called reaction. So here, when A collides with B, there is a force, that is FAB. That is called action. At the same time, B applies a force on A, that is FBA. That is called reaction. So to every action there is equal and opposite reaction. Okay, then what is Newton's second law? Rate of change of momentum is directly proportional to the applied external force. That means F equal to ma. So we can write FAB equal to ma into mass into acceleration. Acceleration means v minus u by t. Acceleration equal to v minus u by t. So va minus ua by t. That is FAB. Next, FBA equal to mass into acceleration. Here Vb minus Ub divided by T. According to Newton's third law, FAB equal to minus FBA. This is called Newton's third law. According to Newton's third law, to every action there is equal and opposite reaction. So in this case, action is FAB, reaction is FBA. To every action there is equal and opposite reaction according to Newton's third law. Then substitute the values of FAB and FBA in this equation. So we can write what is FAB, ma into Va minus Ua by T equal to minus FBA MB into Vb minus Ub by T. On both sides T is cancelled. Okay, then this equation, this Ma is multiplied with Va and minus Ua. Ma Va minus Ma Ua equal to minus MB Vb, then minus MB into minus Ub plus MB Ub. Then we can arrange this equation in an order. Okay, so here Ma Va, then minus MB Vb is given to this side, then minus Ma Ua is given to this side. Okay, so we can write Ma Va plus MB Vb equal to Ma Ua plus MB Ub. So Ma Ua plus MB Ub equal to Ma Va plus mb vb. This is the equation of law of conservation of momentum. Total momentum before collision equal to total momentum after collision. So we can write ma ua plus mb ub equal to ma va plus mb vb. That means total momentum before collision equal to total momentum after collision. This is called law of conservation of momentum. This is called law of conservation of momentum. What is law of conservation of momentum? ma ua plus mb ub equal to ma va plus mb vb. That means total momentum before collision. What is total momentum before collision? ma ua plus mb ub. What is total momentum after collision? ma va plus mb vb. This is called law of conservation of momentum. Using this law, we can explain many problems. Okay, so law of conservation of momentum is rocket propulsion is the application of law of conservation of momentum. Okay, so here we explained from Newton's second law FAB and FBA. According to Newton's third law, FAB equal to minus FBA. Substituting the values, we get ma ua plus mb ub equal to ma va plus mb vb. That means total momentum before collision equal to total momentum after collision. This is called law of conservation of momentum. Next, we can explain problems related with conservation of momentum. First question is, a bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Here we have to find the recoil velocity of the pistol. First, we can write the given data. So, given that a bullet of mass 20 gram. So, mass of the bullet mb, b means bullet, mb means mass of the bullet equal to 20 gram. We have to convert this gram to kilogram. That is 20 by 1000 kg. Equal to, what is 0 and 0 cancel, 2 by 100, 0.02 kg mass of bullet. Okay, bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second. Vb equal to 150 meter per second. We know at the first, that means before firing, bullet and pistol is at rest. So we can write UB equal to 0. Before firing, initial velocity of the bullet equal to 0. Then from a pistol of mass of pistol is 2 kg. What is the recoil velocity of the pistol? We have to find Vp. So Up equal to 0. Before firing, initial velocity of the pistol equal to 0. We have to find Vp. That means after firing, we have to find the velocity of the pistol. This Vp is the recoil velocity of the pistol. Okay, then we know the equation. What is the equation? MA UA plus MB UB equal to MA VA UA plus MB UB. Okay, so here instead of object A means MB UB plus MP UP equal to MB VB plus MP VP. We have to find VP. So we can write VP equal to V. That is the question mark. What is MB? MB means 0.02 into UB equal to 0 plus. What is MP? MP 2 kg into UP 0 equal to, what is MB? 0.02 into 150 plus 2 into V. V means VP equal to V. That is the recoil velocity of the pistol. We have to find that recoil velocity. Okay. So 0.02 into 0, 0. 2 into 0, 0. So left side, that is 0. 0 equal to 0.02 into 150. That is 3 plus 2V. So 3 plus 2V equal to 0. So 2V equal to minus 3. So V equal to minus 3 divided by 2. What is minus 3 divided by 2? Minus 1.5 meter per second. Minus 1.5 meter per second is the recoil velocity of the pistol. What is the recoil velocity? We know when a bullet is fired from a pistol, bullet moves in forward direction. That time pistol moves in backward direction. Okay, the movement of the pistol towards backward direction is called recoil velocity of the pistol. So recoil velocity of the pistol is minus 1.5. Here this negative sign indicates that the movement of the pistol after firing is opposite to the movement of the bullet. Bullet moves in the forward direction. That time pistol moves in the backward direction. Okay, that negative sign indicates the movement of the pistol is in opposite direction of the bullet. Okay, so this is the recoil velocity of the gun. Here recoil velocity of the gun is minus 1.5 meter per second. Okay, before firing, bullet and pistol is at rest. So UB 0, UP 0. After firing, velocity of the bullet is 150. Velocity of the bullet is 150. Then we have to find the velocity of the pistol or velocity of the gun. Clear? So this equation, this question is explained using law of conservation of momentum. Next, second question is, which would require a greater force? Accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square? Here two cases. In the first case, accelerating 2 kg mass at 5 meter per second square or 4 kg mass at 2 meter per second square, which would require a greater force. So we have to find force in both cases. Okay, we know F equal to mn. So we can write F1 equal to m1a1. What is m1? 2 kg into acceleration 5. So 2 into 5, 10 Newton. First case, force equal to 10 Newton. Second case, F2 equal to m2 a2. m2 a2. So here 4 into 2 equal to 8 Newton. So which would require a greater force, 10 or 8? That is 10. So we can write F1 greater than F2. F1 greater than F2. So which would require greater force? F1. So F1 greater than F2. That is the second question. Next, third question. A force 5 Newton gives a mass m1 an acceleration of 10 meter per second square and a mass m2 an acceleration of 20 meter per second square. What acceleration would it give if both the masses were tied together? Here two masses are tied together, then what is the acceleration? Okay, the first case acceleration is 10 meter per second square. Second case acceleration is 20. In third case means both the masses were tied together. What is the acceleration? So we can write what is the equation? F equal to ma. Okay, so we have to find the a equal to f by m. A equal to f by m. What is the value of f? 5 divided by what is m? M is the total mass. Total mass means m1 plus m2. So what is m1? What is m2? First we have to find the m1, then m2. Okay. First we can find the m1. Third question. m1 equal to. So we know f1 equal to m1 a1. So m1 equal to f1 by a1. m1 equal to f1 by a1. What is f1? 5. What is a1? 10. Equal to 5 by 10, 0.5 kg. 0.5 kg. Second case, m2 equal to f2 by a2. f1, f2 all are equal. Okay, f1 5, f2 5, f5 all are equal. So a force of 5 Newton gives. So f1 means 5 divided by what is a2? 20. 5 by 10, 0.5. 5 by 20, 0.25 kg. 0.25 kg. Then if two masses, if both the masses were tied together means m1 plus m2. What is m1? 0.5 plus 0.25 equal to 5 divided by 0.75. 5 divided by 0.75 equal to 6.67. 5 if 5 is divided with 0.75, that is equal to 6.67 meter per second square. So what acceleration would it give if both the masses were tied together? 6.67 meter per second square. Okay, so we have to do more problems in this chapter. We can do more problems in the next class. So today we can conclude our class. Okay, thank you.